chemical formulas look wild and random. Like, have a look at this one. Whose man's is that? By the end of this video, you'll be able to write virtually any chemical formula that you're given. You need to memorize a couple of charges and a simple table. And it's not the periodic table. Where are my manners? It's Uncle Jegs. Let's get started. When you see chemical formulas, you may be wondering, why do you sometimes see small numbers next to the elements? And you may also be wondering, why does it change? Like, have a look at these examples. Why do we have 3 hydrogens in ammonia, but only 2 hydrogens in water and only 1 in hydrochloric acid? You first have to understand 2 things: the periodic table and a valence table. We're going to safely skip the transition metals in the middle there. Notice that the valence of an element is equal to its group number up to group 4. Then after group 4, the valence goes down. So group 5 has 3, group 6 has 2, group 7 has 1, and group 0 has 0. So let's take boron as an example. It's in group 3 and it has a valence of 3. But then when we move over a few spaces, we see nitrogen has a valence of 3 also, but it's in group 5. Remember, it's because when you go past group 4, the valence goes down. Let's do a worked example together. How should we write magnesium chloride? Well, first thing I'll recommend you doing is drawing out a table like this here. Magnesium is in group 2 and chlorine is in group 7. The valence of magnesium is 2 and the valence of chlorine is 1. In this next section, we're going to swap the valences around. The valence of 1 goes to magnesium and the valence of 2 goes to chlorine. And voila, you've got your formula for magnesium chloride, MgCl2. And that's basically it. You get the group that they're in, you work out the valence, swap the valence, and then you've got your formula. Based on the example I did previously, have a go at this one. How should we work out the formula for lithium oxide? Well, first of all, we draw out the table. Lithium is in group 1, oxygen is in group 6. The valence respectively are 1 and 2. We swap the valences around, so we've got Li2O. Notice that when you've only got one of the element, you don't have to write that 1. You just leave it as the element the way it is. So it's Li2O. Also, when your 2 valences are the same, you just write out the formula the way you have the element symbol mixed together. You start with the metal and then you move on to the non-metal. That will make more sense as we move forward. And now have a go at this one. What about potassium bromide? Potassium is in group 1, bromine is in group 7. So they both have a valence of 1. There's no need to swap the numbers around. The numbers are the same. So we just literally write KBr. Remember, we leave out the 1s. And also, if the valences are the same, you leave the numbers out as well. Not gonna lie, this one's gonna look a little bit weird, but have a go at this example. Rubidium is in group 1 and nitrogen is in group 5. So their valences respectively are 1 and 3. You swap the valences around, so you've got Rb3n. Whenever you've got a simple ionic compound like this, when you've got one metal and one non-metal, the metal's name stays the same. So rubidium, that stays the same. But the non-metal, you add an ide. You remove some of those letters at the end and you add the ides. Just like when it's oxygen, we call it oxide. And this one, nitrogen, we call it nitride, okay? So the full name of this compound is rubidium nitride. What about this one here? When we have barium and phosphorus, also try and work out what the name should be as well. Barium is in group 2 and phosphorus is in group 5. So the valences respectively are 2 and 3. So when we swap the valences around, we get Ba3P2. And the name of this weird compound? Barium phosphide. So that's basically how you work out 80% of all the compounds that you'll be receiving in your GCSE. Let's move on to polyatomic ions now. The name polyatomic ion literally stands for many atoms charged, okay? So we've got more than one atom together and the overall group of atoms are charged. That's what polyatomic ions stand for. These are the 4 most common polyatomic ions you need to know. And the next few slides are going to look wild, but just bear with me, okay? Hydroxide ions have an oxygen and a hydrogen bonded together, and it has an overall charge of -1. Nitrate ions have 1 nitrogen and 3 oxygens bonded together, and the overall charge there is also -1. Carbonate ions have 1 carbon and 3 oxygens bonded together, and the overall charge of them is 2-. And the last one is sulfate ions, which have 1 sulfur atom and 4 oxygen atoms bonded together, and they also have a charge of 2-. The purpose of this slide here is just so you can visualize what the charges actually mean. What do these polyatomic ions look like in space? The red small numbers at the bottom show you just how many of that atom on the left that you have. On the nitrate, for example, your small number is 3, and that's next to the O, which is oxygen. So it's telling you that you have 3 oxygens in that polyatomic ion. And the blue number, which is also charged, shows you the overall charge of the full polyatomic ion. And it's that blue number at the top, or if it's just 1, that charge at the top that we're concerned with. That's what's going to help us work out the actual chemical formula. All right. Whenever you have an ion, the valence is equal to the amount of charge of that ion. So if you have a 2+ ion, the valence is 2. If you have a 2- ion, the valence is also 2. In context here, this means that hydroxide ions and nitrate ions both have a valence of 1, and carbonate ions and sulfate ions both have a valence of 2. So I've got this example for you to work out. What should be the chemical formula for calcium hydroxide? Calcium is in group 2, so it has a valence of 2. Hydroxide has a charge of -1, so it has a valence of 1. We swap the valences around, which means we have 1 lot of the calcium and 2 lots of the hydroxide. This is the tricky part here. Because we've got 2 lots of the hydroxide, we have to put brackets and a 2 on the right-hand side of that bracket. But we keep the calcium as just nothing, because remember, 1, you don't write no number when you just have 1 of it. So the full formula for calcium hydroxide is Ca, open bracket, OH, close bracket, 2. If we didn't include the brackets, the consequence of that would mean that we only have 2 lots of the hydrogen and not the oxygen as well. So we needed to put the bracket around the OH so that there's 2 lots of the whole H in total, not just the hydrogen by itself, okay? See if you can work out this one by yourself, calcium sulfate. Both the calcium and the sulfate have a valence of 2. So even if we swap the valences around, they'll still be the same number. Remember, when we have the same number, we don't have to include any of the small numbers showing the valence. But we do have small numbers for the sulfate, so don't get confused there. That means overall, we should have a chemical formula of Ca, no number next to it, SO4. We have to put the 4 there because the sulfate ion itself is SO4. We don't put no brackets around it because the valence of both of them was 2. Finally, try and work out this one, magnesium nitrate. Magnesium has a valence of 2, nitrate has a valence of 1. Swap them around, so we've got 1 magnesium and 2 lots of the nitrate. That means we do need brackets. So we've got Mg, open bracket, NO3, close bracket, 2. So now that we've been through the whole video, you should understand why magnesium nitrate has a formula that looks like this and also structurally looks like this. This is a little bit misleading because it should actually have brackets around it and also the charge above on the right hand side. But that's for another video when we're looking at ionic bonding. Next lesson, we're going to be looking at how you actually balance equations because we're going to need that for the next few topics we're going to look at. Like and subscribe if you found this useful. And if you're still baffled about something, just comment and I'll try and help you out there. Catch you guys later.